Okay, first thing I'm going to deal with the conduction of heat. So I'll just move these down. So conduction is heat being passed on particle to particle to particle. So say for example here, let's pretend this is a piece of metal and those little circles are the particles. So we've got a source of heat here, we've got a flame here, so it's hot. The particles that are near to the heat source, they're going to gain heat energy and they're going to start moving. They're going to have more kinetic energy, they're going to move more, and they're going to vibrate, they're going to move more, they're going to pass that energy on to the next particle, particle to particle to particle. So conduction of heat. So conduction is the movement of heat particle to particle to particle. It takes place in solids. Because the particles, of course, in solids are packed in close together, as we can see. So through them gaining heat energy, moving more, and that heat energy then being passed from particle to particle to particle, that is the process of conduction. Okay, so let's move these out of the way then. Oh, I forgot about something. I forgot about the fact that I'm going to show you this as well. And this, I'm going to explain a little bit here about the heat transfer by conduction in metals. Now these little circles here represent electrons. So in a metal, electrons are free to move. So electrons are part of atoms and they're free to move. So as the metal is heated up, say for example at this end here, the electrons will then start to move through the metal, passing on the heat energy. And that is why metals are better conductors than other materials, than non-metals. Now let me shove these out of the way. I'm now going to explain convection. Okay, so convection, here we go. Convection. Now this tends to take place, instead of in solids like conduction, tends to take place in liquids and gases. And how can I make that bigger? Is it going to let me make that bigger? No, it's not, and I don't really know why, but it doesn't seem to want to get bigger, which is a shame. Never mind. Okay, so here's the radiator there. Okay, the particles in the air that are near to the radiator, they're going to gain heat energy, and as we've learned before, if they're gaining heat energy, in fact, let me draw them. That's what I'll do. So if they're gaining, now it won't move out of the way at all. What am I doing now? I don't know what I'm doing. It won't let me move that. Okay, so the particles, let me try and draw some particles. So these splodges represent the particles. This is a dodgy diagram. And let's say that's the heat source. So if these particles start to gain energy, what's going to happen to them is they are going to start to spread out. So instead of being close together like that, let me try and draw again. Thought I could just move them apart, but it's not going to work. They're going to spread out like that. Okay. Now if they've spread out, they are, and we can see it there, it says here they become less dense. So because they are spread out, their density is lower and they're going to rise upwards. Okay, so this is why hot air rises. And then the cooler air will move down to replace it. So you get what we call a convection current, where the warmer particles are becoming less dense because they've spread out, as we can see. Okay, and they start to move up, and then the cooler particles start to move down to replace them. So you get the movement of air in this way. So this takes place, so air is obviously a mixture of gases. This takes place in gases, but also in liquids as well, because particles in gases and liquids are free to move. So as they gain heat energy, they start to spread out, and they start to then move upwards. Okay? They start to move upwards because they become less dense. Alright, that'll do. 5 minutes on that. If you're still stuck, give us a shout in class. See you later. Goodbye.